We have question number 4 of exercise 8.2. ABCD is a trapezium in which AB is parallel to DC and BD is a diagonal and E is the midpoint of AD. As you can see here, ABCD a trapezium in which this AB is parallel to CD and BD is the diagonal. E is the midpoint of AD. A line is drawn through E parallel to AB. This is parallel to AB. It means EG is parallel to AB and GF is parallel to AB as well. Show that F is the midpoint of BC. We have to show here F is the midpoint of BC. So firstly we will write the given ABCD is a trapezium in which AB is parallel to DC, BD is the diagonal and E is the midpoint of AD. To prove F is the midpoint of BC. So in proof we have as this BD is intersecting this EF at point G. BD is intersecting EF at G in triangle BAD. This BAD. In this triangle we have E, the midpoint of AD, and EG is parallel to AB. As given, this is parallel to this. So by converse of midpoint theorem, this G will be the midpoint of this BD. By converse of midpoint theorem, we can say G is the midpoint of BD. Now we will take this triangle. As we proved here, G is the midpoint of BD and also this FG is parallel to AB and AB is parallel to CD. It implies this FG will also be parallel to this side, and if this is the midpoint and this is parallel to this, so we can say here by the converse of midpoint theorem again F is the midpoint of BC, hence the result. So in triangle BDC, G is the midpoint of BD and FG is parallel to AB, AB is parallel to CD, implies FG is parallel to CD. Thus, by the converse of midpoint theorem, we get F is the midpoint of BC, hence the result. Question number 5. In parallelogram ABCD, E and F are the midpoints of the side AB and CD respectively. So here we have ABCD, a parallelogram in which E is the midpoint of AB and F is the midpoint of CD. It implies this AE is equal to EB and this DF is equal to FC, means this portion is half of this and this portion is half of this. So firstly, from here we will prove that AECF is a parallelogram. So actually we have to prove that is asked in the question. The line segments AF and EC, this AF and EC trisect the diagonal BD. So in solution, firstly we will write given ABCD is a parallelogram. E and F are the midpoints of AB and CD respectively. When we use the word respectively, means E is the midpoint of this AB and F is the midpoint of this CD. To prove or to show that AF and EC trisect the diagonal BD, so we have proof. As we know, ABCD is a parallelogram. It means in a parallelogram the opposite sides are parallel. So AB is parallel to CD. Also, the half of that AE will also be parallel to FC. AE parallel to FC. Now, in a parallelogram, we also have a property that opposite sides of a parallelogram are equal. That is, AB is equal to CD. Opposite sides of a parallelogram. It means half of AB is equal to half of CD. Implies AE is equal to FC. As I told you, E and F are the midpoints of AB and CD. So this implies AECF is a parallelogram. AECF is a parallelogram. By applying A is equal to FC and A is parallel to FC, we can say that AECF is a parallelogram, and on this basis this AF is equal to EC, implies AF parallel to EC. Opposite sides of a parallelogram. Now in triangle DQC, we will take this triangle CDQ, DQC. In triangle CDQ, F is the midpoint of CD. F is the midpoint of CD, and this PF is parallel to QC, implies this P is the midpoint of this DQ. P is the midpoint of DQ by converse of midpoint theorem. And if P is the midpoint of DQ, from here we can say this DP is equal to PQ, implies DP is equal to PQ. Take this equation as A. Similarly, in triangle, now we will take the another triangle, this APB. So in this triangle, A is the midpoint of AB, and this is parallel to this side. So we can say by the converse of midpoint theorem, this Q is the midpoint of BP, implies BQ is equal to QP. So the same we have written here, E the midpoint of AB, EQ parallel to AP. Converse of midpoint theorem says Q is the midpoint of PB, implies PQ is equal to QB. So ये हमने B equation मान ली. So on combining A and B, we get DP is equal to PQ is equal to QB. Hence, line segments AF and EC trisect the diagonal BD